Good day everyone, this is Sarel van Grenen aka Mr. VG and I'm excited. Yes, you hear that correct. I'm excited for today's lesson and you will hear me saying that repeatedly because I want to infuse you with my enthusiasm about mathematics. I want my passion to spill over into your life and to get you excited about mathematics. For today's lesson, we are going to look at unique objects that are rearranged. So in other words, I'm going to look at an example where we've got cards, and because the cards are different, they are unique. We're going to look at people. They might ask you about cities. They might ask you about different textbooks, different books that need to be arranged in a library. Ladies and gents, whenever you see an example where they ask you about unique objects, I encourage you to do it the same way I do it. In this specific example that we are going to have a look at, they tell me that the cards below are placed from left to right in a row. They are giving me 3 cards that are diamonds, a 2, a 9 and an 8 of diamonds, and they give us 3 hearts. So 10, a 4 and a 7 of hearts. In how many different ways can these 6 cards be randomly arranged? If I look at the first spot on the left, if I place the first card down, there are 6 options. Then I move over to the next one. There are 5 options. So in other words, it's actually a very simple sum that it's simply going to be 6 factorial, because in the first spot there are 6 possible cards, for the second spot there are 5, for the third spot there are 4, 3, 2, 1, which means there's a total of 720 possible answers or possibilities that could exist. If I look at the second one, is where life starts to become a little bit more interesting. For the second one, ladies and gents, I'm now going to start drawing pictures. So I'm going to say, it asks me in how many different ways can these cards be rearranged in a row if the diamonds and hearts are placed in alternating positions, meaning that there are no diamonds next to each other, neither are there hearts next to each other. So the first option is I place the diamonds in position 1, 3 and 5, and then the hearts will fall in between. Or, and this is the important word or, because then you've got to start thinking about plus, I could place the hearts first and the diamonds second. So let's have a look at both of these possibilities. Firstly, there are 3 different diamond cards to choose from. I could, if I place down a diamond there, it's either going to be the 2, the 9 or the 8. Then if we look at the second diamond we placed down in the first option, there are now 2 diamonds left. And lastly, there's 1 diamond left. We're going to repeat this process with the hearts. The first heart I placed down, I've got 3 cards to choose from. The second one, I've got 2 cards, and the third one, I've got 1 card. Now again, because we're working with a fundamental counting principle, I'm going to multiply those options. Now let's look at the second option. Exactly the same thing's going to happen. So when I place down the first heart, there will be 3, then 2, then 1 option for the hearts, and the same with the diamonds. Because we're working with a fundamental counting principle, we're going to multiply them. And because of that secret little word there in the middle, we're going to add them together. So if I get the total, there are 72 different ways that we could place the diamonds and the hearts in alternating positions. Be careful of just thinking about 1 option. There's actually 2. When I look at 11.2.3, you'll see there's a word that makes it a bit different. What word in 11.2.3 makes it different from the previous question? You might have spotted it, and the word is probability. So in other words, I can't just give them the number of ways, I've got to give them the probability of this event happening. So let's have a look. They're telling me all the cards are randomly arranged, but now they want the hearts next to one another. Well, I love to say, let's then place them in a box. So I'll have a box with 3 hearts in there. Then the other ones are still going to be on the outside. Now, exactly where that box of hearts are, that I don't know. That could be placed first, or at the end, or in the middle. Well, let's have a look. If I now look at the 4 objects, meaning the box and the 3 diamonds, there's going to be 4 possible answers. But I must never forget that inside the hearts there's 3 factorial different ways. So my total number of ways are 4 factorial times by 3 factorial, which is 144. Now do not go and celebrate yet, young Padawan. Do not celebrate yet, because the question was probability. So what are the probability? What is the probability that the hearts are placed together? Well, that's 144 over 720, because remember, there are 720 different possibilities if there was no restriction. So, the final answer, ladies and gents, sorry, let me just stop this thing quickly. The final answer is 144 over 720. So to finish off the sum, we need to calculate the probability of the hearts being placed together. To finish off the sum, we need to calculate the probability of the hearts being placed together. Now the probability of the hearts being placed together, yes, is the 144. But how many possibilities are there? Well, 720. And there you've got your probability. 144 over 720. Simple and easy as that. There you've got your 8 marks. Fantastic. This next sum, I love to ask my students, because this next sum is a lovely little sum that is all about groups of people hanging out. And I know how much you all love hanging out. So if there were 3 girls and 3 guys that go out together, let's call them Leah, Sam and Marge, Liam, Simon and Micah. Those are the 3 gentlemen. Now I was lazy to think of very creative names, so forgive me, please forgive me. But I've got 3 questions that I want to ask you. First of all, how many ways can they sit in a row? So if they just choose their seats randomly, in how many ways will they be able to sit in a row? Well, let's draw our scenario. I've got my 6 different options. In the first block, the first person to choose has got 6 different options to choose from. Now that person chooses. The next guy chooses, and they've got 5. The next person got 4, because now 2 seats are chosen, etc., etc., etc. Which means, if I multiply them together, it's 6 factorial, which we saw earlier was 720. If I look now at the second question, the second question asks, calculating how many ways can boys sit on the ends. So I love to draw my little picture there. So my two end blocks are going to be my cement blocks. In the first little block, there are three boys that could go and sit there. Liam, Simon, and Micah. Or Micah. But now, one of them goes and sits down. So how many boys are there left to sit there at the back end of the row? Well, there are two of them to choose from. So, what about the rest in the middle? Well, there's no restrictions on how. So the first person will have 4 seats to choose from, then 3, 2, and 1. And because we're working with a fundamental counting principle, we are going to multiply them. And my answer is again 144. Interesting that this 144 and 720 are in 2 examples. It's not planned, it's really a coincidence, believe it or not. I'm not lying, I promise you. But let's look at question 3. Now this question 3 is one of my personal favorites because it's going to rattle a lot of students when they ask you the probability that Marge and Micah do not sit together. If you're going to try and draw that one, I just tell you good luck. Good luck with trying to draw that. So what we are going to do is to try and get the probability that Micah and Marge not sitting together. I'm going to use the complement rule. Now the complement rule says that I could rather look at the probability of them sitting together. So in other words, let's put them in a box, even though they might not like it. Let's put them in the box. So in my options, I'm going to place those two lovely youngsters in the box together. So how many options or objects are there now? Well, now there are 5 objects. So the total number of ways, that's the box and the 4 others, will be able to move in 5 factorial different ways. But don't forget in the box. So in the box there are 2 factorial different ways that they could sit. So in other words, the number of ways that Marge and Micah can sit together is 5 factorial times by 2 factorial. But that's still not the question. The question was probability. So to get probability, I divide it by how many possibilities there are if there were no restrictions. And there are 720 different ones, which leads me towards 0.3 recurring. So if I want to go the probability of them not sitting together, it's going to be 1 minus that 0.3 recurring, which is 0.67. So about 66.6 recurring percentage. That is the percentage of the probability of them not sitting together. Ladies and gents, I encourage you, when 2 things or 3 things are placed together, put them in a box and don't forget to multiply by the possibilities of the movement in the box. If things have to be on set positions, place them in cement. But don't forget about how many different options there are inside the cement as well, like we looked at with number 2. Ladies and gents, there are so many different possibilities that they could ask you when it comes to probability, the fundamental counting principle. But it will either be identical or unique objects. Draw those pictures and calculate them. Now you go and be awesome and have a wonderful day. Remember to subscribe because this is Mr. VG signing out. Have a wonderful rest of your day. Cheers.